Today we are continuing on with Unit 3 on quadratic functions. We're looking at Lesson 5 where we are solving equations. So it says to solve an equation means to find the values of x that make the expression equal to 0. Solving an equation means finding the value of x that makes the equation true. Here it says, solve for the x-intercepts of a quadratic function. Let's say of a related quadratic function, because sometimes you're not finding a function's x-intercept, you're finding a different function's x-intercept in order to proceed. So the roots, the x-intercepts, the solutions, all of these things mean very similar things. We'll try to make sure we clarify the difference between these as we go on. Now, first thing to notice here about solving an equation is that you already know one way of doing it. And one way of doing it is to factor. So for example, in this case, you're looking for a sum of 4 and a product of negative 60, and those two numbers are going to be positive 10 and negative 6, right? So if you go ahead and do your decomposition, you get 4x squared plus 10x minus 6x minus 15. You go ahead and group, you get 2x plus 5, minus 3, 2x plus 5, and then you have your 2x minus 3 and 2x plus 5. Now, this the entire time was equal to 0 on the other side, and factoring is a useful way of telling when a quadratic equation is equal to 0, because we know there are only two ways that these two brackets could multiply and make 0. Either the first bracket is 0, right? Either 2x minus 3 is 0 or 2x plus 5 is 0. Those are the only two choices you could have, because how else could you multiply two numbers to get 0? There's no other way to do it. So in the first case, you get x is 3 over 2, or x is equal to negative 5 over 2, right? And those would be the two solutions to the equation. So if you go back to graph this one for a sec, so 4x squared plus 4x minus 15, and we ask this, where are its roots, right? By typing roots of f, which is the function's f. You see that one root is located at 1.5, which is 3 over 2, and one of them is located at negative 2.5, which is the negative 5 over 2. Graphically, these two roots are the x-intercepts of the quadratic function that we started with. Okay? And that's how you can solve an equation by factoring. Now, when you look at the second one, okay, the second one has a problem before we begin. That problem is that, I'm just going to move this down for a sec. The problem with the second one is that what we're seeing here is not equal to 0. So you might start this one, you might think, okay, 9x squared and 12x, I can factor out 3x, I'm left with 3x, take away 4, and then it's good, right? Except that there are many ways that these two numbers could multiply to make negative 4, right? It could be negative 1 and 4. It could be negative 2 and 2. It could be negative 1/2 and 8. It could be negative 1/4 and 16. And you kind of see how there are an infinite number of ways that two numbers can multiply to make negative 4. You could think of an endless list of numbers that do that. So the first thing you need to understand here about solving a quadratic, when you factor, factoring is only useful if one side equals 0. If the side is not equal to 0, then factoring really has no benefit, because all you're doing is you're factoring, and then you're telling me that two numbers multiply to make negative 4. Well, I can't narrow that down. Whereas here, you told me two numbers that multiply, like the two numbers, i.e. the two brackets, multiply to make 0, then you can actually figure out what those numbers are. Okay, so let's try this one again, and this time let's bring everything over to one side. Okay, so now we have this. So with the plus 4 moved over to this side. I'm looking for a sum of negative 12 and a product of positive 36. Those numbers are negative 6 and negative 6, so I get 9x squared, 6x minus another 6x plus 4. Factor out 3x, I get 3x take away 2. Then I'll factor out negative 2, and I'll get 3x take away 2, and I get 3x take away 2 twice. Because this one's actually a perfect square, right? If you noticed, the square root of 9x squared is 3x. The square root of 4 is 2. And if I take those 3x and 2 and combine them and double them, I can get to 12, right? So that's why you can factor this as a perfect square. That would mean, right, when we go to draw this one, so we get 9x squared minus 12x plus 4. Sorry, 12x, not 12. There's only one answer this time, right? So let's hit factor g. Factors g into the thing that we said it factors into, and it only has one root, right? So if I type roots g, doesn't always know how to do this. Let's try, root g between 0 and 1. Oh, there we go. I'm not sure why that happened. Okay. Anyway, there's an answer there at 2/3, right? Oh, 2 over 3, which is the solution that we got. So in this case, what we say is 3x minus 2 is the thing that could be 0, and therefore x is 2 over 3. At 2 over 3 would, it happens twice, right? But it's still only one answer because it's just one number. The last one, a little bit easier. Here we're asked to, again, factor. One side is already equal to 0, so it's kind of already ready to go. We factor out an x, we get x minus 8. So there's two ways that this could be 0. Either the x could be 0, or the x could be 8. Right? So those are the two different ways that equation could be equal to 0. Okay? So that's how you solve when you are solving by factoring. Now, of course, there are many quadratics that are solvable but not factorable. In other words, they have roots, but those roots are not easily found by factoring. Just imagine we had a quadratic where, the x was, it ran through at a complicated decimal of a number, right, instead of at a regular number. We can make up a quadratic here, so 3x squared plus 7x plus 1. And it has roots, right? But those roots are not numbers that I'm going to be able to find easily, because there's no two numbers that multiply to 3 and add up to 7, right? I can't use my factoring to get this, although you can clearly see that there are, in fact, answers. So what we're going to be doing here is using the quadratic formula to solve. Quadratic formula is really useful way to solve quadratic equations, because if the equation's in standard form and one side's equal to 0, then all you have to do is use this formula, and it will always be able to give you an answer if there's an answer to be found. So the quadratic formula, just to remind you, is this. So it's x equals negative b plus or minus the square root of b squared minus 4ac over 2a. That will be the solutions to the equation. So to do this, what we're going to do is just look at the equation we have. The equation I have, a is 1, b is 6, c is negative 11. Right? It's just the number that goes with, remember that the standard form of a quadratic is ax squared plus bx plus c equals 0. So in our case, the a is a 1, the number in front of the x squared, the b is a 6, the c is a negative 11. So now what I do is I just take these numbers and put them into my quadratic equation, and I just replace them. So where I see a b, I put 6. Where I see an a, I put 1, well, bracket 1. And where I see C, I'll put negative 11. On the bottom, I'll replace the A with a 1 again. Okay, so this is me using the quadratic formula now to solve my equation. Okay, so I get x equals negative 6. Let's just copy this again so it'll be a bit faster. Okay, so inside the bracket here, 6 squared is 36. Negative 4 times 1 is negative 4, times negative 11 is positive 44. And on the bottom, I just get 2, because 2 times 1 is 2. Okay, so then I look at this one more time, and I go x is equal to, negative 6 plus or minus root 80 divided by 2. Now, here's where something else comes into play that we should make sure we understand. It says, find the exact and the approximate solutions. So let's go ahead and do the approximate solution first. So let's keep it in blue, and we'll go x equals negative 6 plus square root of 80, and then we have to divide that number by 2. And then the exact same thing, but minus the square root of 80, right? So if you just type each of those things into your calculator, you're going to get, let's just go ahead and we can do this here. So I'm going to go negative 6 plus the square root of 80, and then divide that number by 2. I get 1.47. And it says round to the nearest tenth. So instead of keeping 1.47, I'm going to put this almost equal to 1.5, right? 1.47 is 1.5. And then the other one, we'll do negative 6, take away root 80 this time, and we get 7.47, which I'm going to round to negative 7.5. Now, here what you're seeing is the approximate solutions to the equation. And all that approximate means is we've done it, and we've rounded it, and we've given an answer. Now, suppose you're asked for the exact answer instead of the approximate. Then you got to go back to this step, and you're not allowed to actually put the square root into the calculator. So what we need to do instead is try to simplify the root and write it as simply as possible. So let's use what we know about radicals here to break down root 80, right? Root 80 is 2 times 40. And 40 is 2 times 20. And 20 is 2 times 10. And 10 is 2 times 5. And if you'll notice, what I have here is a sequence of values that are all prime numbers. And we did the prime factorization of root 80, right? Which is the way that you do this in order to simplify the root. So what I can do now, remember, each pair of numbers I can take to the front. So there's a pair of 2's, then another pair of 2's, and then there's a lone 5 that I have to leave under the root. So I end up with 4 root 5. Okay, and that's what I can replace root 80 with. Okay, so I go back to my question now, and I can write it again, but this time with using this 4 root 80 thing to make things a bit simpler. So let's go back to my answer, and instead of saying root 80, I'm going to say 4 root 5. And over here, I'm going to say 4 root 5, right? So what I've done is just basically replaced the root 80 with a simplified equation. Now, what this lets me do is I can now factor 2 off of the top, right? So let's factor out a 2 from the top. This 6 becomes a negative 3, and this 4 becomes a 2. If I factor out a 2 on this side, this 6 becomes a negative 3, and this 4 becomes a negative 2. Okay, now this is useful because the 2 on the top and the 2 on the bottom can be cancelled because everything is inside a bracket. Oops, sorry. Okay, and I can actually get a fairly simple answer, which is x equals, let's just keep this in red, sorry, make sure this is, okay, negative 3 plus 2 root 5, and then negative 3 minus 2 root 5. And again, this, if you actually put these numbers into your calculator, right? So let's try this. So negative 3 plus 2 root 5. Just quickly go ahead and do this. Negative 3 plus 2 square root 5. Of course, we get the same number we got before, the 1.47, right? Except this time, it's not rounded. It's the full value because we left the radical in. So let's just summarize this by, if you are asked for the approximate solution, type the square root into your calculator and round the final answer to the required number of decimals. If you are asked for the exact solution, you must not put the square root into the calculator and instead try to simplify it. And you know what I'm going to say there is review lesson 4, where we worked on how to simplifying radicals. Okay, so that's what you're doing there if you're asked to find the exact solution versus the approximate solution. Okay, so the approximate solution, you're using your calculator. The exact solution, you're using your skills of reducing radicals. Okay, this last question, it's asking us to use the quadratic formula again, so let's just to practice. I don't think this is a good question to use the quadratic formula, just to be clear, because it doesn't have a b value. And so it's much easier to solve this equation if you just bring the 2x to the other side. So 2 is equal to x squared. Oops. And therefore, plus or minus square root 2 is equal to x. Like, this is a way easier way of doing this than using the quadratic formula because there's no b value. But just so our notes have it, let's go ahead and do it with the quadratic formula. So the a value is negative 2, the b value is 0, the c value is 4. I'm going to just go ahead up here and copy paste my quadratic equation. I know one side's equal to 0, so I'm all good here. I could just go ahead and use my quadratic equation, and we're going to replace everything with what we know to be equal to. So wherever I see b, I'm replacing it with 0. Wherever I see a, I'm replacing it with negative 2. Wherever I see c, I'm replacing it with 4. Okay, and I end up with this equation now. So let's just... Okay, so on the bottom, 2 times negative 2 gives me negative 4. Then inside the bracket, I have 0, which I can just get rid of. Negative 4, well, actually, just look at this. Negative 4, negative 2 can cancel the negatives. And then, look, it's a square root with double 4s in it. So I'm going to bring the 4 to the front and get rid of the 2 4s on the inside. I'm going to get rid of this 0 because it really isn't important. And I see that what I have here is x equals 4 square root 2 divided by 4, or, sorry, the first one, they're both negative, or the second one, I have positive 4 square root 2 divided by 4. Now, of course, you can see these simplify. In the first case, your negative 4 over negative 4 just becomes positive root 2. In your second case, your positive on the top and your, negative on the bottom become a negative 1 in front. Okay, so you get to the same answer. Positive root 2 or negative root 2. Again, you can use the quadratic equation to solve something like this. It just isn't necessary. Okay, next one. We're looking at a business that sells parts. The profit function is modeled by this equation. So they're giving us the profit function right off the bat, where x is the quantity sold, and P of X is the profit in thousands of dollars. How many parts must Anthony sell in order for his business to break even? Okay, so remember, to break even, if your profit, P of X, is equal to 0. Now, there are going to be two ways that you can break even. You can break even if you sell just enough, or if you charge just enough. Remember what the shape of the profit graph is. Upside down parabola, right? So it's not just going to have, if the company can break even, it's likely that there will be two ways to break even, right? So let's go ahead and try this one. So let's write our quadratic formula again. So negative b plus or minus b squared minus 4ac over 2a. Okay, so there's our quadratic equation. In our case, what we're looking at, a is negative 0.5, b is positive 8, c is negative 24. Okay. Okay, and we're just going to do this. We're going to use the same equation. We'll just replace everything we see here with the required number. So we get negative 8 plus or minus 8 squared minus 4 times negative 0.5 times negative 24. And we get 2a on the bottom is a negative 0.5 again. So we'll go ahead and take this and just clean it up a little bit. So 8 squared is 64. Negative 4 times negative 0.5 is equal to positive 2 times negative 24 again. All of this goes down to negative 48. On the bottom, we have 2 times negative a half, which is negative 1. So what we get here is x equals negative 8 plus or minus the square root of 16, right? 64 minus 48 is 16. And all of this is being divided by negative 1. Sorry. It's got to be on the top as well. Okay, so again, negative 16, or root 16, we know we can simplify. Negative 8 plus or minus 4 divided by negative 1. So we get two answers. X equals negative 8 plus 4 divided by negative 1, which would be equal to positive 4. Or x would be negative 8 minus 4 divided by negative 1, which would be equal to 12. So there are two ways this company can break even: if it sells 4,000 units or if it sells 12,000 units. So therefore, the company will break even if it sells 4,000 or if it sells 12,000 units. Again, let's just take a quick look at what this equation looks like for a minute, so I can just make a point about this. Okay, so here's your profit function. As we expect, there is an ideal number of things that he should sell. So let's just sort of break this up into a couple of points. So let's make a separation at x equals 4 and at x equals 12. So in the first region, okay, so what's going on in this region here? He is charging too much and not selling enough. Negative profit. He is losing money. Okay, that's what's going on in this region here between 0 and 2. So let me just make this a little easier to see. Okay, let's get rid of the grid. Keep the axis, I guess. Okay, so if you're in this first region here, like between 0 and 4, your profit's negative because your costs are too high, you're not selling enough. Your sales are low, and we know that sales are low when prices are high. Now, alternatively, over here, you are charging too little, you're selling a lot, but at low value, and your negative profit, you are losing money. Okay, so if he's selling more than 12, basically the idea would be he's charging so little that in order to sell that many, that he's losing money there too. Now in the middle is, of course, he's positive profit, so charging an appropriate amount to make profit. Okay, so that's what the middle sort of section is. Now the 2 points that we found. Okay, so the 2 points we found. So this one and this one. Okay, these 2 points are the break-even points. So these are the points at which he can, it's exactly enough that he makes 0 profit. So let's just say 0 profit, break-even, because he is selling just enough. Okay, so that's what's going on. That's what's going on here. Okay, he's just selling enough to break even on that side. On the other side, he's just charging enough to break even. If he lowers his price any more, he's going to start losing money. He actually should be raising his price in this situation, right? So those are like all the different sections of the graph and what you might need to know. Of course, there's also one more special point, which is the best possible scenario, right? Where in this case, it would be given by 8, is if you take the 2 break-even points, 4 plus 12, you get 16. You divide by 2 to find the vertex, you get 8, right? Which would be sort of the ideal spot. So when you're doing this one, just to try to keep in mind, sorry, lost my train of thought there. Okay, when you're doing this one, just remember, like, there are different sections of this graph, and the different sections mean different things, right? It's a question I like to ask. It's quite common for me to ask. Okay, so just as a picture there's kind of like what we're looking at in that equation, in that question. Okay, now a couple more to do. There's a population of the town. Okay, population of a region in thousands can be modeled by the function p of t is 0.2t, so a is 0.2, b is 6, and c is 30. Okay, and t equals years since 1970. Therefore, 1970 is t equals 0. Okay, please make sure you do not sub in 1970 into this equation. If you want to know the population in 1970, so example for question A, it's asking P in 1970. You do not do this. P of 1970 is asking this equation, what will the population be, 1,970 years after 1970, in the year 3840, right? Or 3940. That's, it's way off. It's going to give you an answer that's way too high for it to make sense, right? What you're actually being asked to do here is find P of 0, because 0 is the year, that's 1970, right? And P of 0 in this question is pretty easy to see that it's 30, because if you sub in 0, the other 2 terms disappear and you're left with 30. So in 1970, the population of the town was 30,000. Okay, then we go on to B. It says, what will the population be in 2015? So first of all, I need to figure out 2015 is what t, like what value of t. So I'm going to ask myself, how many years after 1970 is 2015? To do this, I do 2015 minus 1970, and I get the answer 45. So what I'm looking for is P of 45, right? What's the population 45 years after the model began? So I go ahead, I go P of 45 equals 0.2 times 45 squared plus 6 times 45 plus 30. Okay, now P of 45, okay, 45 squared is 1600 plus 200 plus 200 plus 25, so 2025 plus 3 sets of 90 is 270 plus 30. Okay, and so P of 45 is equal to, okay, so what would divided by 5, that would be 405 plus 270 plus 30, and P of 45 is equal to 705. Okay, so in 2015, the population of the region was 705,000 people. Now again, just to make sure I'm doing this right, let's go ahead and graph this. So 0.2x squared plus 6x plus 30. Okay, so this is our model. Again, if you look at the point 0, f of 0, that's the 30. 45 years later, we have 45 and f of 45. And that one is 705. Okay, so there it is. So the population of this region is growing, growing, growing. And 45 years later, it reaches this number of 705. Now, the third question is, in what year will the population be 250,000? So for C, it's asking in what year. Find the value. We need to find the value of t. So we don't know t, but we know that p of t is equal to 250. Now again, don't write 250,000 because the population function already measures thousands. It's the population in thousands. So if I want to know when the population is 250,000, I want to know when my function is equal to 250, right? So 0.2 t squared plus 6t plus 30 equals 250. Now, here's an important point to understand about solving quadratics. When this equation is equal to 250, okay, so y equals 250, you can see that there's an answer here at 21.4 years after 1970. So our answer is going to be 1991.4. And then I think because of the way the question's worded, we're going to round it up to 1992. Okay, but I don't know how to use the equation to get this value. Because how am I going to get this value? If I look at my graph, right, and I do the quadratic equation, it's going to tell me that there's a root at negative 6.4 and at negative 23.66. But these obviously are not the right answer. These are the x-intercepts of the population model. So I'm not going to do the quadratic equation to the population model. That's not going to be effective. Instead, what I'm going to do is I'm going to take the model. Oops, sorry. I'm going to take the model, okay. I'm going to let me draw this one more time. So let me just show you. We're going to take the model where it is. We're going to shift it down exactly the right number of units, 250 units, so that we have a new model where I can find the x-intercept. Okay, so look at the graph I drew here in black. Let's just simplify it. I drew this. I took the original graph and shifted it down 250 units. Now I can use the quadratic formula to find its x-intercept. So let's go back to this question. What does this mean in the question? Remember, the quadratic formula only gives an answer if one side is equal to 0. So what we need to do here, we need to bring that 250 over to this side, which was the same thing as moving the graph down 250 units. So I end up with a new graph, right? I end up with this equation, and now I can try to use my quadratic formula to solve it. Okay? So my quadratic formula, again, that's what it is. This is what t is equal to in our question. T equals. And in our case, a is 0.2, b is 6, and c is negative 220. Okay? So I go ahead and I open up my quadratic equation. I put those parts into it. So b is, replace that with 6, replace this with 0.2, replace this with 6. 6 squared, 0.2, and negative 220. Okay, so I've got this. If I can solve this equation, it'll tell me the times that I need. So I get, let's see, 6 squared is 36. 36. On the bottom, 2 times 0.2 is 0.4. In here, okay, so I have 0.2 times 220, which is 44. So you get 1/5 of 220 is 44. So this becomes negative 44. And then 4 times negative 44 is 160 plus 16, which is 176. And it should be positive because they're both negative. So plus 176. Okay? So then what we're going to do here is we're going to go 36 plus is, what is that? 212. And we don't need the, I think we only need the approximate because we don't need the exact answer. So let's go ahead and just plug this into the calculator. So we get negative 6 plus or minus root 212 over 0.4. So t equals negative 6 plus root, actually let's just find root 212, so make this a little easier. Square root 212 is 14.56, so plus 14.56 divided by 0.4, or negative 6 minus 14.56 divided by 0.4. Let's find out these two answers. So in the first case, we have 8.56 divided by 0.4, which is 21.4. Or, in the second case, we have negative 20.56 divided by 0.4, which is 51.4. Now, in these questions, notice that it says t is the number of years since 1970. So when we say t is a negative 51.4, that would be before 1970. That would be like in 1919, right? And that obviously is not an answer that makes sense in this picture. The reason the math is giving us that answer is because if we look back at our question, there is another time that the model says that the town had a population of, 250,000. It was way back here in negative 51 years before the model started in 1919. But the model doesn't exist back here. So we're going to reject this one, right? So we reject t equals negative 51.4 because the model only works for years after 1970. In other words, t has to be greater than or equal to 0, right? You can't take a negative time. So our answer is 21.4. Now, so 21.4, so let's just write this down. So 21.4 years after 1970, the town had a population of 250,000. Now, the question says, let's just look at this, read this carefully. In what year will the population be at least 250,000? Now, think about it. If I give the answer 1991, is too early because it takes until 0.4 of the way through the year 1991 for it to reach that number. So we're going to round it up due to the context of the question. And we'll say 1992 is the first year where the population would be at least 250,000. Okay, which is what we were asked to do. So just be careful on some of these questions where at the end, try and think it through. Do I need to round it up or round it down in order for my answer to make sense? Again, normally you would take 21.4 and round it down, but the question is asking in what year will the population be at least 250,000. If you give the answer 1991, it's actually too early. It doesn't happen until halfway through the year in 1991, right? So we're going to say 1992 instead. Okay, C says the hypotenuse of a right triangle is 10. Of the remaining two sides, one is 2 meters longer than the other. Find the area of the triangle. Okay, so let's write down a couple of things here. First of all, we know that in a right triangle, a squared plus b squared equals c squared, where c is the hypotenuse. So what does the question tell us? It tells us c is 10. It also tells us b is 2 bigger than a, right? Because one side is 2 meters longer than the other side. The area of a triangle is equal to base times height divided by 2, which if you draw the picture, you should have BA divided by 2, because, I mean, let's just quickly draw this one so you can see what I'm talking about. But alright, so what I'm going to do here is I'm going to make a slider for A, be between 0 and 10. We know it's not going to be bigger than 10 because that's the hypotenuse. So side A I'm going to draw first. So let's draw O, we'll draw A0, and then we'll draw 0, A plus 2. So segment Okay, so there's side B. Okay, and then there's side A. We'll just hide this. Okay, we'll rename this to side A. Okay, so there's side A, there's side B. Side C is the hypotenuse between B and A. Okay, now to answer the question, what we want to know is when is the hypotenuse 10? So if you look at my drawing, we can just use the drawing to find this out. Okay, so there's the answer. A is 6, B is 8, and the hypotenuse is 10. Now the area of this thing would be the base, which is A, the height, which is B, and then divided by 2. So you get area is base times height divided by 2. In our case, is B times A divided by 2. Before we know how to do this, though, let's go back to our original equation and write down what we know. We know that A squared is A squared. We know that B is A plus 2 squared. And we know that C is 10 squared, right? Or C is 10. C squared is 10 squared. So let's expand this. We get A squared plus 4A plus 4 equals 100. Remember, this bracket here, A plus 2, needs to be FOILed. Right? So make sure make sure you're foiling that. You're not just squaring the two values. Right? So we get this. We get 2A squared plus 4A minus 96 equals 0. Let's divide everything by 2. Okay, so we get this equation. A squared plus 2A minus 48 equals 0. Let's factor. Two numbers that add up to 2 and multiply to negative 48 would be A plus 8 and A minus 6. Therefore, A could be negative 8 or A could be 6. Now, I'm going to reject A equals negative 8 because lengths must be positive. So I'm going to reject that one. So therefore, A equals 6, which means B equals 8, because B is two numbers bigger than A. And the area is 6 times 8 divided by 2. 6 times 8 is 48, divided by 2 is 24 units squared. Okay? If I go back to my drawing here for GeoGebra, and I ask this to draw a triangle, A, B, C, notice that it draws a triangle with an area of exactly 24, which is the right answer for what we need. Okay? So that's that one. It's a pretty straightforward question. You just need to follow along with the idea of a, the right triangle, the hypotenuse, and all that stuff for your Pythagorean theorem. Okay, so there's your answer for that one. Now the last one says two whole numbers differ by 3. So again, we'll say one number is A, one number is A plus 3, because it's 3 numbers bigger than the one we got, right? So we get this, A squared plus A plus 3 squared equals 89, because it says the sum of their squares is equal to 89. So I'm going to take the two numbers and get them equal to 89. So let's go ahead and FOIL the same way we did last question. Excuse me. And we get 2a squared plus 6a plus, minus 80 equals 0. Again, let's factor. We get let's divide by everything by 2. A squared plus 3a minus 40 equals 0. Now, two numbers that add up to 3 and multiply to negative 40 would be a plus 8 and a minus 5. And so you get a could be 5 or a could be negative 8. This means the other number could either be 8 or negative 5, because the other number, remember, is 3 higher than the one we found. Now, in this question it says two whole numbers differ by 3, the sum of their squares is 89. Now, a whole number is a positive integer. Integer, remember, means no decimals, and a whole number also means no negatives. So what we're going to do here is we're going to reject, therefore we reject the pair of values negative 8 and negative 5 and keep the 5 and 8. So the two numbers are 5 and 8. So if you forget about a whole number, of course, you could ask me a question like that. You don't need to remember what a whole number is, but just so you understand why I'm rejecting the negatives here, you would not reject the negatives here if it just said two integers, because negative 8 and negative 5 also work, right? You can square them and you still get 89. So the fact that it says whole numbers is the reason I'm getting rid of the negatives. Other than that, I would keep them normally. Okay, so just to end up with today, when you're solving a quadratic, I want you to remember that unless one side is equal to 0, you're not actually solving it. So make sure that one side is equal to 0, just like what I did here, right? It was equal to 89. I bring the 89 over so that it's equal to 0. Remember that you can use your quadratic formula to solve. Usually if you can factor, it's faster to factor, but you're never sure whether you can factor or not, so sometimes it might be good to just get in the habit of using the quadratic formula. If you notice that any of the numbers are not, nice, small, or easy numbers, but the quadratic formula, if there is an answer to be found, it will find it. The quadratic formula, if there is no answer to be found, will give you a negative number under the square root here, and that's your way of saying there are no solutions, there's no way to answer this question. Okay, so that's it for this lesson on quadratic equations and using them to solve. Try the questions from the homework and feel free to post anything else to the discussion area.